Hello everyone, welcome back to my video. I'm glad to see all of you today. How's it going? I hope you're doing great. In this video, I will introduce you the new concept, the application of derivatives. By the end of our lesson, we will learn the monotonicity of the function on the intervals depends on the first derivative and recognize the local extrema of the function. Now let's get started. Now, see the figure 1. This graph shown in figure 1 is rise from A to B, falls from B to C, and rise again from C to D. So the function is said to be increasing from A to B, decreasing or from B to C, and increasing again from C to D. And now, notice that if I take any number at between A and B, x1, x2, with x1 less than x2, so fx1, fx2, fx1 here, fx2 here, fx1 is less than fx2. So the graph is raises. So the function is increasing. So we have the definition of the monotonicity of the function. Now let's move on part 1. Determine the monotonicity of a function. We have the definition 1, A, part A. Definition 1. Let K be an interval or a closed interval or a half-closed, half-open interval. Let y equals f of x be a function defined on K. The graph, the function y equals f of x is monotonically increasing on K if for all x1, x2 belonging to K, x1 less than x2, then fx1 less than fx2. And the function y equals f of x is monotonically decreasing on K if for all x1, x2 belonging to K with x1 less than x2, then fx1 greater than fx2. So remember, we have the function is called increasing if x1 less than x2, then fx1 less than fx2. And the function is called decreasing on k. If f(x1) less than x1 less than x2, but f(x1) is greater than f(x2). Now, how the derivatives affect the shape of the graph? Let's look at the figure 1 again. Between the point A and B and C and D, the tangent lines have the positive slope. So f prime greater than 0. Between B and C, the tangent lines have a negative slope, so f prime of x less than 0. Thus, it appears when the function is increasing when f prime of x is positive, and the function is decreasing when the prime of f is negative. Now let's go to the definition 2. Definition 2. Given a function y equals f of x, differentiable on k. If f prime of x is greater than 0 for all x in k, then the function y equals f of x is increasing on k. And if f prime of x less than 0 for all x in k, then the function y equals f of x is decreasing on k. But in some case, like we have the graph of the function xq. Let me draw the graph of xq. Right, that is the graph of the function xq. So we can see at the point x equals 0, so the tangent line has the 0 too. So the graph is still increasing on the interval from negative infinity to infinity, right? So we have to expand the definition 2. So we have the definition 3. Given a function, now let's write down y equals f prime of x. Differentiable on k. If f prime of x greater than or equal to 0 for all x in k, and f prime of x equals 0 at only finitely many points on k, then the function y equals f of x is increasing on k, and if f prime of x less than or equal to 0 for all x in k, and f prime of x equals 0 at only finitely many points on k, then the functions y equals f of x is decreasing on k. So look at again three definition 1, 2, 3, and to determine where the function is increasing or decreasing, you can follow 4 steps. Now, 4 steps to determine where the function is increasing or decreasing. Step 1, find the domain of the function. Step 2, calculate the derivative of f of x, f prime of x. So, and find the critical point where f prime of x equals 0 or f prime of x is undefined. Step 3, make the variation table, or you can see a sine diagram or the variation table. To make the sine diagram or variation table, you must arrange the critical point on step 2 from smallest to largest. Now, step 4. Use the side of diagram to conclude where the interval where the function is increasing and decreasing. 1. Determine where the function, or find the function f of x equals 3x to the power of 4 plus minus 4x cubed minus 12x squared plus 5, where is increasing and decreasing. Now, solution. Before we solve the example 1, look at again 4 steps to determine where the function is increasing or decreasing. So we do follow 4 steps. Step 1. The domain of the function f of x is real number because the function is the polynomial function. So that means the domain is always real number. Now next, step 2, we calculate the derivative of the function f. So we have f prime of x equals, now we can say 12x cubed minus 12x squared minus 24x, and find the critical points by so the equation f prime of x equals 0. So that means we have 12x cubed minus 12x squared minus 24x equals 0. And you can solve quickly. X equals 0, x equals -1, and x equals 2. You can solve this equation by using the calculator, right? Now, with step 3, make a sign diagram or variation table. Now, let me show you how to draw the table. Now, step 3. To draw the table, the sign diagram, the variation table, we draw a table with 3 rows. 3 rows. The first row represents x. The second row represents f prime of x. And the third row represents f. In the first row, you can write the domain of the function, negative infinity to positive infinity, and arrange the values of x from smallest to largest. So we have -1, 0, and 2. At the critical point -1, 0, and 2, the prime of f equals 0. So we have 0 here. To find the sign in its interval, you can look at again the f prime, and look at the highest, the coefficient of the highest degree term here is key. We have 12. So the sign of the last interval, is the same as the sign of the highest coefficient. So we have 12 because 12 is positive. So in the interval 2 to positive infinity, we have positive. Okay, and go through the root of the odd multiplicity, and the sign is changes. We have negative. So is change the sign, we have positive. Change the sign, we have negative. And on the interval from negative infinity to -1, because f prime is positive, so the function is decreasing. So we draw the downward arrow. And next, on the interval from -1 to 0, the f prime is positive. So we draw the upward arrow. And do the same with 2 intervals. And now, we use a calculator to calculate the values of f in its critical point, or you can plug -1 into the original function, and we have, now let me check. Now, I can use the calculator to calculate the values of at the critical point, and you can use the button CALC to calculate at the point -1 equals 0, at 0 equals 5 and at 2 equals negative 23. Now, at the negative infinity and positive infinity, we can use the negative 999 and 999. You can remember the good. So we can calculate positive infinity and positive infinity too. So we finished the variation table. Now look at it again. Use the sign, the variable variation table to determine where the function is increasing and decreasing. We can see the function is increasing on the intervals -1 to 0 and from 2 to positive infinity. Okay, because f prime of x is positive. And the function is decreasing on the intervals from negative infinity to -1 or 0 to 2. Now, let's move on to the part 2 to determine part 2. Look at the figure 2. The graph shown in figure 2, we can see f of x0 is less than f of x. For all x belonging to the interval a to b, so x0 is called the local minimum point. And in the figure b, f of x0 is greater than f of x for all x belonging to the interval a to b, so x0 is called the local maximum point. So if the function has the local maximum point and the local minimum point, so the function is called has the local extrema point. Now let's move to the part 2. Local extrema point. Definition 1. Given a function y equals f of x defined on a set D, and x0 belonging to D if there exists the interval from A to B containing x0 and the interval A to B belonging to set D if f such that f of x0 greater than f of x for all x belonging to the interval from A to B except x0, then x0 is called the local maximum point, and f of x0 is called the local maximum value of the function. if f of x0 less than f of x for all x belonging to the interval from a to b except x0, then x0 is called the local minimum point, and f of x0 is called the local minimum value of the function. And let's look at the figure 2 again. In the figure A, you can see we have the tangent line, and the interval a to x0 is have the negative slope, and here is positive slope. So you can see the sign of f prime is changes from negative to positive. So that means x0 is called the local minimum. And do the same with the figure B. You can see the sign of the f prime is changes from positive to negative. So x0 is called the local maximum point, right? So we have the definition 2. Now let's move on to the definition 2. Given part B, definition 3. Given a function y equals f of x continuous on the interval a to b and differentiable on a to x0 and x0 to b if f prime of x greater than 0 for all x belonging to the interval a to x0 and f prime of x less than 0 for all x belonging to x0 to b, then the function has now from positive to negative has the local maximum point. And if f prime of x less than 0 for all x belonging to from a to x0 and f prime of x greater than 0 for all x belonging from x0 to b, then the function has the local minimum point. If the function has a local maximum and a local minimum point, so we can call the function has the local extrema point. Okay. Now let's move to the example 2. Now, before we move to the example 2, let's look at the again definition 1 and definition 2. So to find the extrema point of a function, you can follow 4 steps. Now we have 4 steps. Step 1, find the domain of the function. Step 2, calculate f prime of x and find the critical point where f prime of x is equal to 0 or f prime of x is undefined. Step 3, make a side diagram. Step 3, conclude the extrema point. Now we have the example 3. Find the extrema of the function y equals x cubed minus 6x squared plus 9x plus 30. Now you can find the extrema of the function with 4 steps. Step 1, we have the domain of the function is real number because it's a polynomial function. We have the notation d equals r for all real numbers. Now let's calculate the derivative of y. We have 3x squared minus 12x plus 9. And so the equation s prime of x equals 0. So we have the equation 3x squared minus 12x plus 9 equals 0. And so for x we have x equals 1 or x equals 3. Now let's make the side diagram. Because you make the side diagram in the example 1, so in this example I will go so fast. Do the same. We have 3 rows: x, y prime, y, negative, infinity, 1 and 3. Remember to arrange the values of x. And positive infinity. Here is 0 because 1 and 3 is the roots of the equation. Now the sign. Now let's look at again. The coefficient of x squared is 3. 3 is positive, so that means the sign in the integral here is positive. And change the sign when you go through the odd multiplicity, so we have negative, positive. Draw the upward row, downward row, upward row, and we calculate the value is here, and we have 34, 30, and negative infinity, positive infinity. And based on the side diagram, you can see the local maximum here. So the function has the local maximum at x equals 1, with the local maximum with the local maximum values is 34. Or you can write the notation like this: y equals 34, and the function has the local minimum point at 3, and the local minimum value y is 30. So that's it. And that's all for today's lesson. I hope it's useful for you, and thank you for watching video until the end, and goodbye everyone. I'll see you in the next video. Goodbye.